immunology is too big. So you got to learn B cell immunology, T cell immunology, mucosal immunology, innate immunity, or what happens. And then what happens? Then they learn that area, and then they go into a laboratory, and they're given a very narrow project. So 4 years or 5 years later, when they get their PhD, they know a lot about that little project, but they don't necessarily know a lot of immunology. And it's a problem. And it's a very different, our scientists today are trained very differently than in the past. One of the things I urge people is to read biographies. Read a biography about Marie Curie. Read a biography about Albert Einstein. I will tell you that Albert Einstein will not have been able to come up with a theory of relativity without his philosophical training. He read Kant before he was 18. And Schopenhauer greatly influenced his thinking. So he has a very large philosophical understanding, and then he approaches a problem in physics. And what I would say is that, unfortunately, look, I'm trained the way you were trained. I went into a program and I was very rapidly specialized. So I think we have to do it ourselves. And I can tell you that every day I try to read outside my area. Let me give you an example of things I've been reading about. I've been reading about the Webb telescope. It's out there. I've been reading what is the Grandian point. Why is it out there? How do they cool? Why does it take 4 months for it to be cooled? Why do they have to wait until they take a picture? No more than 5 to 10 minutes until today. You can Google it and you can and try to read something outside. And what you find is that if you do that every day, in 1 year, you would have learned a lot. And then you begin to make connections. So, and then you can supplement that by reading about biographies in the field. And then try to always go deeper. Like I, for example, just said to you that Einstein would not have been able, in my opinion, to derive the theory of relativity without his philosophical training. Is Arturo right? Is he making that up? You could Google it and try to see, how did classical philosophy influence what is thought to be, what the greatest scientific mind of the 20th century. You could imagine that if we were trained, had that background, that the questions that we would ask are different than if we just get trained very narrowly. So in answer to you is, it's unfortunate we're all caught into this right now, but you're taking a course with a philosopher. So you're already in a different place than your fellow students. And now what you can do is you can supplement that on your own.
Yeah, and maybe one could add that also say artistic training. We talk a lot in our course of the science and human values, and I've written an essay on this, on the contrasts and subtleties. So art and philosophy and science are full of contrasts and subtleties. So, for instance, maybe a painter will use different colors or different shapes. A musician will use different tones or different rhythms, but we use different molecules, right? And maybe one day we find that molecule A does something, molecule B does something else. But when you put them both together, they do a third function, right? And so that's the creative thought, that's contrast and subtleties, and that's in the arts and in philosophy.
Edmundo, that's right. And I give you another suggestion. Have you thought of getting a watercolor and making your own pictures for your slides?
No.
So I do that.
Oh, wow.
I
always wanted to do that.
You can look up some of my papers. I basically have just, and I will spend no more here in the United States. You can get a watercolor for less than $2 or $3. And I sit there and For example, I have a review that I wrote with Ferrick on intracellular pathogen concept. If you look at it, there is a figure, a single figure. That's a watercolor. I just drew it.
Okay.
It's a very different experience if Stella is working with Salmonella, do the pathogenesis in watercolors. It's a very different experience than if you do it in PowerPoint. And it's a lot more fun. And you know what? Nobody can copy it. It's your work.
Excellent. We'll look it up. Okay, Isela, you had something you wanted to say.
Yeah, I want to talk about the part of the pedagogy because in grad school exists a hidden curriculum. Even if the research professors are not aware of its existence, they are perpetuating certain behaviors in the academic environment at social and cultural level. And these not technical skills could be important for a successful career in academia. So the educational reforms in science should not only be aimed at the student level but also toward the advisors. Do you think that it's important that professors are aware of what they teach through the hidden curriculum? And
Yes.
if so, how can it be promoted to be accepted among professors? They need to know that they need to learn too, not only the students. And
so it's hard. What you're asking is hard because you're asking people to change the way they teach, to acknowledge that what they're teaching represents a point of view and that there are other points of view, correct? And that's what you would like. Now,
yes.
It's very hard to go up to Arturo and say to him, hey, you just gave me a talk on fungi, and that is your point of view. There are other, but I think you can do it in a gentle. First of all, what I like, what my advice about thing is always be very easy on the person and be tough on the message. Always assume that when people are doing something like this, it's not because they're blinded. They haven't even thought about it. So one way in which you can engage is if you can think of something that is scientific that could be presented on a different thing, and that you can then tell because the example. Let's say I gave you the example that I'm teaching on Wednesday morning. I'm preparing a lecture. So my hidden curriculum in it is my biases as to what is immunity to bacteria. But you could imagine that if you looked at that, when I covered it, as you pointed out to me, I say, Arturo, you have too much antibody there. There are other ways to do that. It will allow me to do a self-correction. So what you do is you focus on the lecture. You don't focus on the person. Because if you say, Arturo, you have a hidden curriculum and you're trying to indoctrinate me on antibody, then I get all defensive, and then that often stops the conversation. But if you say, I would like more coverage on this, or I would like you to, the hidden curriculum could be that when I talk about the history of it, I basically focus only on European discovery. It'd be nice if you included then that's another way to do it. So what I would say, Isela, is the important thing is to engage. And don't be afraid to engage, but try to engage on the science. Because that is something that one can always talk about. And assume that the hidden curriculum it's just, they always assume that they don't know, that is the case. Does that answer you?
Yeah, a little bit, but I still have some sensation that the responsibility of learn new things only is from the students and not for the professors. And that I don't think is the best option in academia. I think that we need to learn all of us, not only the students. But also
I agree with you. I mean, I agree with you. The But what I would say is that this will be something in which it may be good to read The Prince. You know, The Prince, Machiavelli.
Machiavelli, sure.
Machiavelli.
Mhm.
Sure.
Mhm.
And to focus on what the end. I don't
Right.
mean to say the end justifies the means, but how to change it without worrying too much. Because the fact of the matter is that you may not like it, but it is the students that catalyze change.
Right.
It is you who catalyze the change, and we are all settled. We need to be challenged. And what you would like is that we challenge each other so you don't have to do it.
Yes, just as Arturo had mentioned previously, the changes are most likely to come from the students.
Exactly.
And so maybe so a group of you who are taking Arturo's course on immunology can get together and say, we'll talk to Arturo, we'll do this gently, and we'll tell him that the science should be broader, or we have other questions, say, paraphrasing Arturo, we know that there's also cell immunity and we're more interested in such and such process. Can you elaborate more on this or that? So maybe that's the one of the ways to do this. And I wanted to add some when you talk about a point of view, it's not only in the courses, it's also when you direct or tutor a student in a project, right? I mean, not you, but I'm talking about researchers in general. You want a student to work on a problem, and you have a question, and you as a tutor, as a researcher, as a professor, it should be ideally aware that that is a point of view. So maybe the student will obtain data that does not conform to what Ludwig Fleck would call the harmony of illusions, right? And you're probably familiar with the Ludwig Fleck's work on the generation of scientific thought, fact. And so again, this when we are tutoring in the lab, we want our students to get a certain set of data of with a prefixed point of view of what we should obtain or what we should see. And if something comes out does not conform to the illusions of the time, then we don't understand it or we ignore it. And so then again, the tutorship in the lab, I think, also runs into such problems. What do you think?
I kind of agree. I mean, as a species, we're very good at we can transfer among generations information. We cannot transfer experience. Therefore, every generation tends to relearning everything. Hopefully, they do it a little better. And that's how we kind of make progress. I mean, I think that one of the things that happens to all of us is that as we go up in faculty, we become more fixed in our ways. And it'd be great if it can come from us in many, but often we need the challenge to be able to change things. And to me, the challenge is when somebody says precisely, you're not teaching me this, or this is your bias. And I said, oops, let me try to fix it. I wish I could see it, but I often don't.
Okay, so now we have, do you want to say something more? Go ahead, Isela, please. With your microphone.
Just a little bit. Yeah,
Go ahead.
That part in the science part, but what about the humanistic approach of the relation, the advisor at BC? How do you say to your advisor that he has a bias in the formation, social and cultural, not only in the scientific part?
So it's very hard. Okay, it's very hard. But what I would say is that conversation, And what I would think is that a lot of times the indirect approach is better than the direct approach. What do I mean? The direct approach is to go in and say, you have a bias in how you're teaching me. You know, the first thing people do is they get very defensive. But you could say, you know, we're focusing on mosquito diet. It is possible, you know, that what matters here is the light cycles. You see what I mean? Because I'm just using that as an example, that you say, this is what we're focusing in. I know you want me to work on mosquito diet. I know you think that depending on what they eat, they're more likely to bite people or not. But I think that it may have to do with the light cycle. Can we talk about it? And that is what I would say is the way to change, in my experience, is to move away from the personal, to try to engage in areas in which you can change. And because, you know, at the end of the, but what you are asking is difficult. I'm not saying this is easy.
Okay, I see. Okay, thanks.
We can come back later. David, Felipe, you had something you wanted to show us.
Yeah, well, I wrote an opinion about a subject about the human values that I want to share with all of you, not only with Arturo. And I need to show you something. It's a small slide, just like 2 slides, but I need them because it's an interactive thing. So let's see this and this and this and this.
Haydn.
Yeah, I'm sorry. I'm also a musician, so
Yeah,
I'm going to talk about music. Well, first, I'm going to tell you about history. In 1772, composer Joseph Haydn and his musicians were forced by their patron Prince Nicholas of Hungary to stay longer than agreed in his summer palace. Haydn was very angry, composed his Symphony 45 that he named the Farewell Symphony. And in the score, he instructed the musicians to leave the stage towards the end of the music as a matter of protest. After its premiere, the prince understood the message and allowed Haydn and his musicians to return home. Today, we have heard that a growing number of graduate students around the world experience intense emotional stress, lack of encouragement to collaborate, sudden mood swings, chronic depression, generalized anxiety, suicidal ideas. Measurements have been taken to contain such situations. For example, psychological care services, psychotherapists, university mental health programs, and guided and specialized counseling. However, these measures are only palliatives for fundamental problems. To paraphrase Henry David Thoreau, 1,000 cuts on the leaves of the tree of evil equals 1 on its roots. I believe that these issues rise from a not deficient or inefficient education in pedagogical, ethical, moral, philosophical, and leadership issues. We are not taught about emotional intelligence or interpersonal relationship or work psychology or emotions management or leadership or teamwork. Even more serious, there are people who are not interested in learning from these kind of things. As a scientific community, I believe we require individuals who know about assertive communication, critical, philosophical, and diverse thinking, leadership, pedagogy, proactivity, collaboration, delegation capacity, and task delimitations. All of the above must be based on values such as humility, empathy, respect, trust, responsibility, adaptability, efficiency, tolerance, resilience, among others. We are not born with these values, but it is our duty to cultivate them like any good habit. We all have flaws, and it's not a bad thing that we are not prepared about these issues. It's not a bad thing to be wrong or to not understand. The bad thing is not wanting to recognize it and not doing something about it. We must work together to change the old paradigms that are now obsolete. Let's build better habits for ourselves and for the relationships we have with other people. That a graduate program does not focus on training scientists, but on forming human beings with values who are dedicated to doing science. Let us avoid that the academia becomes a psychological hell for people, which the only thing it causes is the proliferation of anti-values and the desertion and abandonment of academic life. Finally, if we do not recognize these problems and seek to solve them, science will eventually suffer from the consequences. And let the Haydn's Farewell Symphony deliver this message. And I just hope that all of us, all Prince Nicholas, can understand the message. Thank you.
David, that was beautiful. That was a beautiful presentation. And, you know, I can't imagine anyone on this call or Zoom meeting disagreeing with what you said. I think we all agree, and I think the issue is how to implement it. You know, and what I would say to you is that I'm fortunate enough to be getting older. And so I have seen a bit. So I can't transfer you experience, but I can transfer you information. And I can tell you that things are getting better in terms of how we relate to students and to colleagues. The craziness that I saw when I was a graduate student, the abuses are now largely gone. They're not gone by any means. They still happen, but things are getting better. But what I would say is that they're getting better because of presentations just like the one you did. And I cannot support it. Look, what the only thing you didn't say was that we need to fix this for our own survival, because science is the only ticket out for humanity. If we don't fix it, and science doesn't fix the problems that we're about to deal with this century, humanity will get poorer, and we're going to see this will be, you know, people, if you read history in the Middle Ages, People look at the ruins of Rome, and they knew they could not build buildings like that. Nobody knew how to make a dome anymore. We don't want next century to people to look back at this time and say, we cannot do things because the world has been so degraded, and because the only ticket out for the 7 billion of us is science, getting that carbon out of the atmosphere, figuring out how we're going to make it, making things, plants that grow with very little water, et cetera, figuring out hate, figuring out what's going on in people's heads. And that requires what you put in. It requires a system to function even better than it is functioning today. So.
Thank you, David, Felipe. As you all noticed, Arturo used the key word, beauty. We talk a lot in our course about the search for beauty. And in the end, at least this is my own bias, that's the reason for humanity. It's the search for beauty. And you search for beauty when you do science, when you do art, when you do philosophy, when you do history, when you do sports. It's all the search for beauty throughout our creativity. And David presented me this idea last Friday. I thought it was great. It was beautiful. And I really thank him for it. And you know, this is the caliber of our students. Our students are very creative. These students are very profound. And as Gondola Bosch mentioned, your colleague, what we need to form is thinkers, not specialists.
Right.
And so our students are confronted with a wide variety of experiences. And then let me go and elaborate a little bit about what David mentioned. And, you know, we talk about putting the PH in the PhD, the philosophy into the doctorate of philosophy, understanding that philosophy and science at one time were the same. And sometimes many of our colleagues do not understand why should a student, say a graduate student in the biological sciences, should learn philosophy. They should be learning how to, you know, how to classify a microbe or how to isolate a protein or clone a gene, right? And sometimes that is viewed as a waste of time. I could also say that there are some of our colleagues that insist, say, on training in business, say, and that's important because if you are trained in biotechnology and you want to set up a company that makes vaccines, in our case for Mexico, say, why shouldn't you be able to be trained in some of these areas of business or business development, you know? And then there are other colleagues that say, oh, you should not do that because science is all academics, right? So we have this point of view where you have, you know, focus on the central courses or the central concepts of biological science, and don't go outside this. And you can, the same thing can be said about pedagogy. You know, we are teachers, but we learn how to do it by our own experience. Or how do you do science communication? Now it's so important. It's always been important, but many of us have dedicated a lot of time to educate society on, especially now with COVID, but way back, about how science works and how science tries to solve the problems. And how do you communicate that? It's not the same. You can talk about children in the kindergarten. You can talk about adults that have no science education. You can talk to adults who have no education or barely any education. And so there's so many skills. So what we've been trying to make aware our community is that our formal programs should include these courses. you can take the credit and study philosophy, and that will enrich the person. You can take credits and you can talk about science and learn about how to do science education. You can take credits and learn how to set up a business, or and so on and so forth, or the intricacies of the law, of the legal requirements that have to do with science, with patents, and so on and so forth. So that's the general idea, and I don't know what you think, or how can you comment on this?
I have a lot of thoughts. The first thought I have is for Felipe, that you should record a YouTube message or something in that you presented to us and get the word out. Practice it on it. The second thing was Edmundo began to say, and use a very interesting example. The first example that Edmundo used was, well, you're told that you should classify bacteria or something. To me, that's a philosophical question. When you begin classification, is that a scientific issue? Are different bacterial species different? How do you classify them? Where do you set it? Or is it Aristotle coming from 2,000 years ago, dominating things by put things into classifications? Are we superimposing an Aristotelian view on nature? Yeah, you can imagine that bacterial taxonomy, things that would drive you crazy, are very profound questions. So you put things in bins or not? And I will say to you that you cannot be a good taxonomist, you can't be a good molecular biologist without some understanding of what you're doing. Of course, you may be able to do this and write a paper into a single word journal, but you need to have that understanding. The fact that since kindergarten, in our way of life, they've been telling you to classify things, put all your green toys in one place, put all the yellow stuff in that thing. Is that reality? What if it isn't? And we're spending all this time separating E. coli from Klebsiella or something. You cannot ask that question without philosophical background. So that's what I think. Edmundo example tell you why you need to. And I would say to you the same thing in immunology, all these things, think about what we do. You know, you go to an immunology course, we're going to break this down. You do facts. We're breaking things into subsets. Is that real?
Well, it's very interesting because Gisela had mentioned, she's working on a project where she's classifying salmonella, or trying to classify salmonella. And she's come to the conclusion that it's hard to classify salmonella, right? You know, you can use this and that molecular tool and serotyping and so on and so forth, but in the end, it's very hard. You know, and we were talking, and I said, you know what you should do? You know what the best thing? And she's a witness right now. I told her, what you should do is you should take our course on science and human values, and we should talk about, you should spend thinking for a semester on philosophy, and you'll see that your project, you'll see it with other eyes, you know, in another context. And I think it worked. And so it's exactly what you're saying.
Isabella, imagine, for example, that instead of being brought up in sort of this Western view of classification, you have been brought up with a philosophy of continuity. So your world is all continuous. You don't see differences. You see similarities. Think how different your science will be.
Yeah, and we just read Fleck about the harmony of illusions, and was fantastic to learn that we could break that barrier. And it's amazing because we always want to classify things, but things not always need to be classified. We need to study everything in the context we find it. Not necessarily we need to put it in a box and say, okay, this is it. So the course, it really helps me to
that awareness requires some degree of philosophical. Why do we classify?
Mhm.
I mean, the idea is that you know, it's the Aristotelian idea. You break down things into the simple things, you know, and you try to understand it. But it is, you are putting in a human view into biology that may not be real. What is the outcome of doing that to biology? Are you going to get the right answer? I don't know. I don't know, but you can't ask the question without knowing philosophy. Felipe o David, ¿cómo prefieres? David, Felipe?
David.
David, a ver, David.
Yes, okay. Yeah, I was thinking about this idea that well, first of all, I think that science can be viewed as a categorical and organized philosophical knowledge that we try to use to understand the universe. And in this, what we are talking about, I remember a piece of music, sorry. I remember a piece of music that can be used to criticize what we know about something. As a scientist, we apply the scientific method and all of that, but also we have to make some questions that are more fundamental. What is true? What is, how can I give how can I say my experiment is going in the right direction? What is that direction? Where am I going? That kind of self-questioning about science and the scientific work. And there is a work, a music work, that is from a philosopher called John Cage, that is called 433. And you say, well, what is 433? And it's a critic about what we know about music. The work is 4 minutes and 33 seconds of silence. And the idea behind that, that music is there is no concept of silence. There is something making noise. And there is something that idea, that concept of silence is somewhat meaningless. It's difficult to understand because there is no real silence. And then we try to philosophy on the subject. I think that kind of exercise must be done on the scientific community, on the science on our daily basis, to try to search for those answers. I mean, what is the purpose, or what am I doing, the things I'm doing? All in the idea to try to be the best, to try to reach through true scientific knowledge, or just knowledge in general. But I cannot avoid the analogy. I don't know if you find it interesting also.
You know, the analogies are very, very powerful. I find them interesting.
We have now Armando Villegas. He's as I said, he has added a bonus to our course because this is a true philosopher by training. Armando, you had some comment.
Arturo, we have talked about science communication and hidden curriculum and the relation between art and science. I would like to know your opinion about one thing that is concerning to the economical model. It has to do with the conception of knowledge that we have. The idea of the, don't you think it's also a problem, the conception of utilitarian model of knowledge? I mean, the idea of if the knowledge doesn't have an immediate application, it's useless. Don't you think the problematic is also about the idea that philosophy is useless and the science must be application?
I mean, I look, we knowledge is important in its own sake. Knowledge teaches us about the world, whether you could use it or not. The example that I like to use to everyone is Einstein's theory of relativity. It had absolutely no use till the 1970s. In the 1970s, the United States decided to create a military system called the geopositioning system. Why? So they can guide their missiles in. The clocks run differently. You can't run GPS without general relativity. It took 60 years before the usefulness come, but the beauty of it, the way that it explained the universe and the way that it explained itself has a tremendous human value. We want to know. Things don't have to have an immediate utility. Think about all the energy that is being used today. For example, and just to me, one of the best days of my life is February 16th, 2016. What happened on that day? Why is Casadevall talking about it? That was the day in which they announced gravitational waves. Now, to me, that is one of the most best days of my life. So I turn on the news today and totally depressed. I'm totally depressed. I mean, find me something that's going well in the world. But I think about the following, and I give it to you to think about because it strengthens me every day. I think about two black holes spinning into one another 1 billion years ago. Life in this planet is unicellular. We know the size of these black holes. One of them is about 12 times the mass of the sun. How would I know that? Look it up. And the other one is about 14. They spin into one another and they set up a disturbance in space-time. For 1 billion years, this disturbance travels to reach us. Today, we have the age of the dinosaurs. We have, the Jurassic, the Permian, and all that. And then one species builds an interferometer and listens to that. Think about that. This is who we are. And this is what gives me great hope, even though when I go check the news, I'm going to be totally depressed. This is what gives, but this is knowledge for its own sake. I mean, today we capture a gravitational wave, we have no use for it. But think how the world, the universe is going to look when you map it, not by electromagnetic radiation, but gravitational. The map is going to look totally different. And we're going to see our home in a different way. And this is what I say is knowledge for its own sake, philosophy for its own sake. If you know about it, your life is richer. And you have only one life to live. And you want to live the richest life you can. And I would say the questions you're all working on, whether it's SELA's classification, I don't know what your other projects are, have deep philosophical roots. If you know those roots, your thesis is going to look different.
Hey,
It's going to look different.
Yes.
I would say learn them.
Can you wait, Tanya, a little bit? I know you have your hand raised, but we have enough questions. Well, there's a question from another student, Sandra Garcia. She says, hello, everyone. I have a question because the concept is kind of ambiguous to me. How do you define creative thinking? At what point do you say this student is thinking on a creative way and this other student is not?
We're getting into art here, and you can't define art. But what I would say you cannot define art. So creativity is going to have to be, again, one of those things. What I would say to you is an example of creative thinking to me is when a student brings to me, has done something in a different way than was done previously. It usually, if you're following the methodology, for example, we're working on the cryptococcal phagosome. If somebody brings me a characterization of the phagosome based on standard techniques, I would say that's good science. We're learning what's in it. But if somebody figures out a little twist on it that gives you an edge, to me, that is creative thinking.
Bronowski in Science and Human Values talks about creativity as finding the hidden likeness. you know, when two things apparently are not related, but then suddenly you find them. You know, that's what I've found as the best definition to start a discussion. Yes.
Sandra, the other thing you could look when you're looking for creatives is look for the ability to make connections. Often when two things that appear to be unrelated, somebody figures out a way of connecting them. That's an example of creative thinking.
En español sería encontrar los parecidos escondidos. ¿Sí?
Muy bien.
Ok, a ver, Tania, si puedes hacer tu comentario más o menos breve para dar lugar a algunas otras preguntas de la audiencia, por favor.
Muy bien. So, Arturo, you said changes must start with students and that we must be really aware of our own hidden curriculum. But how can we engage students in awareness when the majority do not even know it exists? So how do you do it in Johns Hopkins University?
So Tanya, maybe I misspoke, but I would say they can begin with students. It doesn't always have to. The R3 didn't begin with students. It begins with Gundula and myself.
A word about R3 for our general audience, please, for the professors.
So I came to Hopkins 8 years ago because I became convinced that we needed to train scientists differently. So you still have to do a thesis. You still have to get a first author paper. You still have to learn your immunology. But we want you to know about history. We want you to know, how do you know what you know? We want you to know. So if you go to Google or whatever your search engine is, and you put R3, Hopkins, the program comes up and you see the other courses that we have developed. So in this case, the faculty was not interested. So we created it and the students embraced it. And they became the engines of change, right? Because since they basically said, I want to do this, it ended up then that other people began working that into, and now our curriculum, for graduate curriculum, counts those courses, whereas before they were electives only. So what I would say to you is change doesn't have to come from students alone, but students can often be the great catalyst of change.
¿Alguien más tiene preguntas? Tenemos unos minutos más todavía con el profesor Casadeval, con Arturo. ¿Alguien por ahí tiene alguna pregunta? ¿Comentario? ¿Alguna mano? No veo manos por ahí. Han quedado todos dumbfounded, como dirían en...
Dumbfounded, no. Your job, I give you a job. First of all, I want you to look up things, the things I say, check them. And that alone will give you some things to begin to look and always look further. The second thing is, why don't you recruit another student to this course? Why don't you double the size for next year?
Yes.
You do it. You can recruit it. You can just, for example, look a little bit of the philosophical underpinning of your work and try to engage them in that their work will be better if they understand how to place it. And I want to use this example. One of the things we do in my lab meetings once a year is we do the physics of pizza. So we order a pizza, right? And the first thing you do is I ask them, why can you hold it by the crust and you can't hold it by the middle? And they say, because the middle is hot. But I tell them the crust is just the same temperature as the middle. How can that be? Well, we talk about heat transfer. And then we talk about, there is a book called the Physics of Pizza. And the bottom line is that whether you're eating pizza, if you order a beer, there's a lot of science that you can talk just looking at a beer or a bar. Why do the droplets form in certain places? In fact, you can see that as the droplets begin to go up, it's an exponential distances because they begin to accelerate. And all of this makes a lot more fun, and all of a sudden you can enjoy it in a completely different way. And science becomes alive, and it's really contagious.
Okay, anybody else? I think they're sending me some question over here. So just to wrap up, yeah. So it's you need the authorities to be sensitive to your points of view of this, and then try to engage students and to enjoy these new points of view, these revolutionary points of view, and then everything will come and fall together in its place.
Bueno, Edmundo, muchas gracias. If you want, I'll come back next year.
That would be good. Thank you.
This is something we learned with COVID. We would have never done this 2 years ago.
That's correct. That's correct.
Right?
Okay.
So, out of this calamity, we learned how to.
Yes.
When I came in my office, I just told my people outside, I'm just going to Mexico now. And they laughed.
Excellent, Arturo. Thank you very much. I know you're very busy and in high demand, and we appreciate very much you joining us, and we'll be in touch. Thank you again. You're very, very kind.
Adiós.
Hasta luego. Muchas gracias.
Thank you, Arturo. Nice to meet you.
Nice to meet you too, everybody. Adiós.
Adiós.